Hello, I am Ajiboye Isaac, and this is a lesson series on probability laws, probability distribution, probability density functions, and so many more. Before we proceed to the example, it is important we understudy these important probability identities. Cumulative distribution function (CDF) can be used to determine exact individual probability values. And one way you can see from the left, the general rule is probability of x equal to k is equivalent to f of k minus f of k minus 1. F of k def is cumulative distribution function defined on the value, and that we can get in our statistical table. So once we check the statistical table corresponding to the probability distribution, we'll be able to get the exact value. So for example, if you have in example 2 on my right hand, p of x equals to 5 is equivalent to p of x less than or equals to 5 minus p of x less than or equal to 4. We can also determine probability of x less than 5 to be equivalent to probability of x less than or equal to 4 in example 4. We can look at the other examples there. Take a minute, pause the video to understudy these identities because we'll be making application of it in the example to follow. So these probability identities will be very useful to you. Pause the video, understudy it. In fact, write it down, take note of it, so that by the time we make application of them in the examples, you would find it easy. So let's take a look at this example. In a university, 40% of the students are members of the university dance club. A random sample of 16 students is taken from the university. The random variable x represents the number of these students who are members of the dance club. Using a suitable model for x, state the model and defend your choice. Find the probability of x taking a value of 4, probability of x greater than 7, which can be interpreted as probability that at least 7 students are members of the dance club, probability of x less than 3, probability of x taking a value between 4 and 7. So the suitable model here is a binomial probability model. The reason is because it is a binomial outcome experiment. What do we mean by binomial outcome experiment? So it is either a student is a member of the dance club or not a member of the dance club. There is no in between. There is no any other possible outcome when we randomly select a student. So because it is only this binomial outcome, a binomial probability distribution will be suitable for this problem. And why is it binomial? Because we are doing a couple or a number of students, right? So it's a repeated Bernoulli distribution. And so from the question, we'll see that 40% of the students, meaning 0.4 of the entire population of the students are members of the dance club, right? So which implies that P, probability of success is equal to 0.4. So if we then, our N therefore is equal to 16. So we'll go to the statistical table, locate the probability distribution table, then we'll go to the column for n equals to 16 and locate the column for 0.4, and then we can be able to apply whatever values, read out the values that are in that column. So to get the Roman figure 1, Roman figure 2 question, probability of x equals to 4, the intersection of n equals to 16 and p equals to 0.4 and x equals to 4 is 0.10. Similarly, we can look at the probability of x greater than or equals to 7 as a complement, right, of probability of x less than or equals to 6. So that can be interpreted as 1 minus probability of x less than or equals to 6. If you check your cumulative distribution table, we'll see that probability of x less than or equals to 6 is equivalent to 0.527. So if we subtract that from 1, we'll get 0.437. Then for Roman figure 3, probability for Roman figure 4, I beg your pardon, p x less than 3 will be equivalent to p x less than or equal to 2. If you go back to the previous slide, you'll be able to understand how this general rule applies. How we're able to say that probability of x less than 3 is equivalent to probability of x less than or equals to 2. And if you read that from the value of cumulative distribution values, this will be equivalent to 0.018. And lastly, the probability of x taking value between 4 and 7, 4 and 7 are exclusive, is equivalent to probability of x less than or equals to 6 minus probability of x less than or equals to 4. If you read the value from the table, probability of x less than or equals to 6 is 0.527, and probability of x less than or equals to 4 is 0.167. If you subtract these values, this will be equivalent to 0.36. And this is how we approach a binomial probability problem. If this video has been helpful, like, subscribe to the channel, share with those that may find this video helpful. I'll see you in other videos with more example. Bye.